Hello students, myself Prakyati, working as assistant professor in Department of Electrical and Electronics Department. So this is the second lecture in module 2, that is mathematical modeling of physical system. So as we all know that in the previous class we discussed about open loop control system and closed loop control system. In that we have a physical system over there. So in that physical system we have to modeling that system in a mathematical way. So I will explain how to do this mathematical modeling of any physical system which is available in the nature. So in that modeling of physical system, first we are going to consider it as a mechanical system. So in mechanical system, we are divided as two types, that is translational mechanical system and rotational mechanical system. What do you mean by translational mechanical system? Translational mechanical system is nothing but the movement. So the displacement is going to happen in terms of distance. So such type of system we call it as translational mechanical system and rotational mechanical system. What do you mean by that rotational mechanical system? The rotational mechanical system, we are going to tell the displacement in terms of angular displacement, and the rotation is going to happen in the mechanical system. For example, if you take a vehicle, the movement is going to happen in a translational motion. And if you take an engine, that is taken as an example for rotational mechanical system, because the engine is going to rotate and that engine is connected to shaft of the wheel. So the wheel is going to rotate, then the motion is going to happen, then the translation is going to happen. So these two are the system which is belongs to mechanical system. Then we have a translational mechanical system we taken first as translational mechanical system. There are three basic elements in a translation mechanical system. One is mass, one is spring, and another one is damper or dashpot. So first one we considered as mass. Okay, a mass is denoted by capital M. So anywhere in a mechanical system, if you got a mass, so that is going to denoted as M. Okay, then if a force F is applied on it, see here in this picture, the force is applied in this direction for a mass M, and it displays a distance. So when any mass is going to, if we apply the force for any mass, definitely it is going to displace. So that displacement we taken as x. So you can see it in this diagram. We have x in this. So you have a mass. The notation for mass is m, and the force, the notation for force is f, and the displacement, the representation is x. So for this, how to write a mathematical expression for this mass? So the mathematical expression for this mass is F is equal to m into d square x by dt square. So this is the representation for force in terms of mass. Okay. So if you have a force in this direction, but the displacement in two direction, some system, if you apply a force in one direction, then the displacement is going to happen in a both the direction. So such type of system, you have a displacement as two quantity, that is x1 and as well as x2. So how to represent this in a mathematical form? So the force has to be represented for such type of system is F is equal to m into d square x1 by dt square minus d square x2 by dt square. So this is the representation of mass for a translational system. Next we have a spring. So the spring is denoted by K, you can see here, and if the force is applied to the this spring element, so the displacement is going to happen. Definitely there is a displacement for a spring also. So that displacement we are going to denote it as X. So this is the spring we are connected, and the force is applied here, and the displacement is going to happen. That displacement we call it as x. So how to denote force in terms of displacement and spring? So F is equal to K into X. So this is the mathematical notation for the force for a spring. So if you apply a force in one direction, and because of this there is a two direction displacement is going to happen. So if the two direction displacement is going to happen, so how to represent this in a mathematical model? F is equal to K into x1 minus x2. So this is all about the explanation and the mathematical modeling of spring. Next, we have a damper or dashpot. So a damper is denoted by D, and if the force F is applied on it and it displacing a distance of x. Okay. So this is the dashpot, and we are going to apply the force for this, and the displacement for this is x. So how to denote in a mathematical representation? That is F is equal to D into dx by dt, and if you apply the force for a dashpot and you have both the displacement is going to happen, so that notation is F is equal to D into dx1 by dt minus dx2 by dt. Okay. Then we will move on to the next concept here, that is rotational mechanical system. In this rotational mechanical system, we have inertia, spring, and as well as dashpot. So the mass is replaced by inertia here, and spring is same for both translational system and as well as mechanical system, and damper is also same for both the systems. So next we have the explanation for inertia. What do you mean by inertia? A body with an inertia is denoted by J if the torque is applied. See here, there the representation of force, we are going to apply the force for the translational system. Here we are going to apply torque for the rotational system. So torque applied on it and it is displaced by a distance, that is theta. We call it as an angular displacement. So the representation for this in a mathematical form, T is equal to J into d square theta by dt square. Then if you apply the torque is applied on a body, that is inertia, there is a displacement in two sections, that is theta 1 and theta 2 in an opposite direction. So how to represent that in mathematical form? T is equal to J into d square theta 1 by dt square minus d square theta 2 by dt square. So this is the representation of that. Then we have a spring. Then if you apply the notation for spring is K. If you apply the torque for this spring, then the displacement is going to happen, that the distance is distance for displacement is theta. So theta is nothing but angular displacement. So T is equal to K into theta. So if a torque T is applied on a body with inertia J and it is applied distance theta 1 in the direction of T and distance theta 2 in the opposite direction of torque, then the representation is T is equal to K into theta 1 minus theta 2. Next we have a damper. So damper is denoted by D, and if the torque is applied on it, it displaces a distance theta. So T is equal to D into d theta by dt, and if the torque is applied and the displacement in both the direction, so that denotation is notation is given as T is equal to D into d theta 1 by dt minus d theta 2 by dt. So this is all about rotational and as well as mechanical system, and the problems, all the problems are going to solve in the class. So the theory concept behind this is needed. So I explained in this video. Next we have a mathematical modeling of electrical system. There are three basic elements in an electrical system, that is resistor, inductor and capacitor. And electrical systems are two types. One is voltage source electrical system, and one more is current source electrical system. So if I go for voltage source electrical system, if you take a resistor, how to represent the voltage drop across the resistor, that is V is equal to R into I. So that is the voltage source electrical system representation for a resistor. Next, we have an inductor. So current flowing through the inductor. Then how to calculate or how to tell the voltage drop across the inductor, that is V is equal to L into di by dt. Then if you apply the voltage for a capacitor and current will flows through the capacitor, then how to tell the voltage drop across the capacitor, that is V is equal to 1 by C integration of I into dt. Then the current source system, the same equation we are going to represent in a current form. So V is equal to I into R, then what is the current from that equation? That is I is equal to V by R. So the inductor we have V is equal to L into di by dt. So we are going to integrate on both sides in order to eliminate the differentiation which is in this equation. So if I apply integration over here, so I is equal to 1 by L integration of V of t. So you can see here, I is equal to 1 by L integration of V into dt. So next one, V is equal to 1 by C integration of I into dt is there. So if I differentiate on both sides, differentiate and integration will get cancelled. So dV by dt is equal to 1 by C into I. So C will multiply on this side. So dV by dt into C is equal to I. So I is equal to C into dV by dt. So you are going to get the current source electrical system. So in the next class we are going to discuss about analogous system, how to relate the two system in an analogous in nature. We are going to discuss in the next class. Thank you.